for 1.1. So 1.1 has to do with a bunch of definitions we're going to be looking at, which are sort of the foundation for this course. Those of you who are looking at this digitally, this should be a hyperlink that will send you to the textbook pages that relate to what we're going to cover today. So the first definition I'm going to talk about is the point. A point in geometry means a very specific location, and a point has no dimensions. So this point right here, point A, doesn't have a length or width. It's just a location. The notation for it, so if I want to refer to this point in a problem or on a diagram in words, I can say, I would have to write the word point and then the letter. Now, sometimes you might see references to the point with just the letter, but in that case, the letter has to be italicized. So if I want to say point U, but I don't want to write the word point, you might see a capital U like that. The second definition is line. A line in geometry is an object that has two dimensions, or one dimension, just length, excuse me. So a line doesn't actually have a width. And you can think about a line as a lot of points next to each other. So if you put a bunch of points next to each other and zoom out, it'll look like a line. And the notation for the line, so if I want to refer to this line here, you can use the word line, but if you're going to use one word, you need to use the letter that's outside of the line. So I can't say line R or line S. I would have to say line L. And so the second way is using the 2 points. So I can use RS with an arrow, or I can say SR. So it doesn't matter. You can pick 2 points on the line and put that notation. So this tells me you're referring to this line. The third definition is plane. Now, a plane has 2 dimensions, and so it has a length and it has a width. So the plane in this diagram is this kind of slanted rectangle. Doesn't quite look like a rhombus. So this is a plane. It has a length, it has a width, and you can't see it obviously because this is a diagram, but you need to imagine it's extending forever in both directions. And a plane can have several objects in it. I think there's something wrong with X, Y, Z are clearly points, so they should actually have this. That's kind of missing. So these are points that are in the plane. You can also have sometimes a line. So I can say, call this line AB, is also on the plane. Okay. So if I want to refer to this plane, I can use the word plane, and this italicized M here is referring to the plane because it's by itself and it also doesn't really have a point. So plane, the flat surface, M. So that's referring to this flat surface. I can also name a plane using 3 letters. So you still would need to write the word plane, and you can pick 3 points. Now, the only rule with this is all 3 points can't be on the same line. So if I go back to this line, and let's say I add point C, I can't say plane ABC is actually wrong. So instead, if I'm going to use 2 points from that line, the third point has to be just on the plane, but not on that line. Okay, we're going to talk about this more, but this is a variation that most students forget. So this is kind of important. So these 3 definitions here in geometry, we refer to these as undefined terms. Well, what do you mean by that? Because you just define them. Well, by undefined terms, we can't write on there. Okay. These are undefined terms. By undefined terms, I mean they exist because of observations. So no one had to prove that something was a point. Someone went out into nature and saw that, oh, these things are next to each other, kind of looks like they're in a line, let's call it line. So all of these concepts were based on observations, and everything in geometry comes from these three definitions. So if you put certain line segments or lines together, you form shapes. If you take multiple points, as we talked about, you form a line. So these three are the foundation of all of geometry, pretty much. All right, the fourth definition, I'm going to move a little faster here, is a line segment. Now, the easiest way to think about a line segment is that it is a piece of a line. So it is a piece of a line. Notice it doesn't extend forever in both directions. That means if I had line AB and I just sort of chopped off from point A to point B here, that would be a line segment. Now, the notation for line segment is similar to line. You need 2 points on that segment and you would put this bar here. So A, B, B, A. Now, on the textbook and even in some problems, you'll see the notation for line segment and line look very similar. And not sure why that is, but I'll point that out to you if that happens. But this is the notation for generally a line segment. Okay. Or you'll see for line, you won't see the distinct arrows, but you'll see sort of like tiny arrows. So all of these things are very meticulous. You need to pay attention and maybe even make some flashcards. That would be a suggestion. As if you look at these rays coming out of the sun, and the geometric object looks similar. So the sun is sort of what we call the end point of the ray. So in this case, it's C. And then the ray, it extends forever in one direction, which is denoted by the arrow. And you can think of that as the red rays coming out of the sun. Now, this, as you can see here, the initial point is the beginning of the ray. You're going to see this as also the end point. So if you want, you can also add end point or the initial point, but it has one end point. And the way you would label this ray is you have to start with the initial or end point and then put a mini version of the object on top of the letters. Now, in this case, direction matters. So if you were to say AC, then that's telling me that the picture of your ray actually looks like this. And that's not necessarily true. So it's important that you always start with the end point when you're labeling the ray. Okay, I'm trying to think if there's anything else. No. All right, opposite rays. Now, opposite rays share the easiest way to think about opposite rays is they share the endpoint. So they have a common endpoint, and then they extend forever in both directions. Name opposite rays just like you name any ray. Start with the endpoint. And you can name both of them. You don't really need to change the direction of the ray notation up here. Is because you're making sure you're starting with the endpoint. Okay, so collinear points that are on the same line. So in this diagram, X and Y are collinear. Now I can add another point in here and they can also be collinear. Okay, no notation here. Coplanar points are points that are on the same plane. So X, Y, and Z are on this flat surface, so they're coplanar points. Moving on. The last sort of notes that we'll talk about is intersection points. So intersection points are when two objects cross, right? And the first one is when you have two lines that cross, they cross at a point. So the intersection of two lines is a point. Write this out. Now, I'm going to jump to 3. When you have 2 planes, remember, planes are flat surfaces. So when they cross, they wouldn't cross at a point. So you have this flat surface. You can actually do this with 2 flashcards. And you have this flat surface. So when they intersect, they actually intersect at a line. So 2 planes intersect at a line. Now, the intersection of a line and a plane, so that's the middle diagram here, there's 3 cases. So the pink here is the plane, and this is the line. Now, they can have 0 points of intersection. They can, if the plane is going directly, you can say perpendicular to, if a line is going perpendicular to the plane, it can cross in such a way that it only crosses at 1 point, right? So 0 points of intersection, 1. And then a line can be directly on the plane, and then we can say they have infinite intersection points. So the intersection of a line and a plane is, well, depends. I'm just going to put dot, dot, dot. It depends on where the line is and where the plane is. So there's 3 scenarios here. You could pause this, do the examples on your own, and then check your solutions, and then come back and just listen to the ones that you got wrong. Or you can follow me all throughout the video and listen to all the examples and then move on to your problem set or a weekly check to sort of see if you understood the material. So it's up to you. I'm going to go through these and talk about how you would actually answer them. So name this line in 7 different ways. So there's 7 different ways because remember, all you need to name a line is if you're using the points on the line, you need 2 points. So one way would be AC. I can also call it AB. Now moving on to point C, I can call this line CA, CB, and the same thing with point B. Okay? Now, or I can call this line M. Okay? So 1, 2, 3, 4, 5. That's 7 ways. Okay. So 4 rays in this diagram. 1 ray, I can use A as the endpoint, and AC is the ray I could be talking about, or AB. Now, these 2 are they're the same rays because A to the endpoint C continuing forever is the same as A being the endpoint and using B because it's in the same direction. So these 2 are actually different ways of naming the same ray. So if we want to name 4 different rays, you could do CA. It's not the same ray because C is now the endpoint. You could do CB. Okay. And then you can do BC. Okay. So these 2 are actually the same ray. 2, 3, 4. I'm just going to highlight these 2 because these are the same. Opposite rays, well, remember opposite rays have the same endpoint and they're in 2 opposite directions. So you have CA and CB that are opposite rays. Line segments, it didn't say how many, so I'm just going to name a few. AC, BC, you can say AB. Okay. There are also different variations. As long as you use 2 points on the line, it's a line segment with this notation. Now we're going to use this diagram on the right. Name the plane shaded in 2 different ways. So the plane, remember, is the flat surface. So one way I can name this plane is calling it plane F. Another way is, remember, I can use any 3 points that are on the plane. So that takes away, I can't use point C or point D when I'm naming this plane because they're actually off the plane. So I can name this plane plane A, B, E. Okay. So I guess I'll put a little note here. Can't use point C or point D to name this plane. Okay.